A comet with a nucleus the size of Rhode Island is coming our way, but astronomers believe Earth is not in danger of a don't look up situation. But did you know that this absolute unit of a comet is among many others that we don't even know about yet? Today we'll talk about the new record holder of being the biggest comet ever recorded, as well as the possibilities of much larger celestial objects that we don't even know about yet. Although comets are best known for their long, flowing tails, the heart of a comet is its solid core. The nucleus is composed of ice and dust, resulting in a dirty snowball. Comets are essentially frosty leftovers from the formation of the planets in the early days of the solar system. The Oort cloud is currently the home of distant comets on the boundary of our solar system that reaches into the deep space thanks to the gravity of the biggest planets. When comets' orbits are towed back toward the sun by passing stars, they return to the sun. NASA's Hubble Space Telescope verified the biggest ice nucleus ever observed. According to NASA, the nucleus of comet C/2014 UN-271, dubbed the Bernardinelli-Bernstein, is around 80 miles across. That's more than 1,300 football fields. In addition, the nucleus of the comet is nearly 50 times bigger than typical comet nuclei, and its mass is believed to be 500 trillion tons. Hubble measured this insanely huge ice comet through a series of high-definition images to show how the Bernardinelli-Bernstein comet's nucleus was isolated from a shell of dust and gas surrounding the solid nucleus. This comet represents literally the tip of the iceberg for many thousands of other comets that are too weak to be observed in the more remote portions of the solar system. However, the bizarrely large size, or its perceived strangeness, may reveal more about ourselves and our limited understanding of comets than anything else. The Bernardinelli-Bernstein comet comes from the Oort cloud, a massive, spherical scattering of icy objects thought to surround the sun at the solar system's deepest and most distant reaches. So far away that it is believed to extend at least a quarter of the way towards the nearest star system, Alpha Centauri. Isn't that a big deal? It is, at least in theory. Even though scientists regard the Oort cloud as one of the greatest formations in our solar system, it's so far away and impossible to detect that it's essentially a vast, speculative enigma. But every now and then, something emerges from the mysterious mass, gravitationally drawn to the sun from the far reaches of the cosmos. The Bernardinelli-Bernstein comet is one of these objects, and it has the potential to reveal a lot about the Oort cloud's frozen, perfectly preserved masses. These are assumed to have originated early in the solar system, before being blasted out to the furthest reaches by the gravitational forces of large planets like Jupiter and Saturn. Using archived pictures from Chile's Cerro Tololo Inter-American Observatory, astronomers Pedro Bernardinelli and Gary Bernstein are the ones who identified the comet. The comet has been closely monitored since it was first discovered back in 2010, when it was 3 billion miles away from the sun. The comet's nucleus was difficult to measure, though, since it was too far away for the Hubble telescope to estimate its size. So instead, scientists had to tweak a computer model to suit the photos of the comet's intense brightness obtained from the telescope's data. The enormous comet is still on its trip from the outside of the solar system. Although flying at 22,000 miles per hour, NASA claims that it will never travel closer to the sun than 1 billion miles away. And even then, it won't be until 2031 that it'll be closest to the sun. In 2002, the former record holder for the biggest comet nucleus was found. The comet C/2002 VQ-94 measured around 60 miles wide. Our comet of discussion today is 20 miles bigger. The photograph from Hubble demonstrates how the nucleus of the Bernardinelli-Bernstein comet was separated from a large shell of dust and gas around the solid frozen nucleus. A model of the center panel was generated by fitting the surface brightness profile derived from the observed picture. The bulk of detected comet nuclei is smaller than Halley's Comet. They are usually a mile or less across. The Bernardinelli-Bernstein comet now holds the new record for large comets. But of course, with the JWST up there with Hubble, we could potentially discover bigger comets in the future. But for now, this is the biggest one we've recorded in history. We said that it might just be the tip of the iceberg. As the sensitivity of sky surveys improves with new technology, astronomers may be able to find many more monsters. Though scientists know this comet must be gigantic to have been seen so far away from Earth, one thing is for certain: only the Hubble Space Telescope has the sharpness and sensitivity to deliver a definitive estimate of nucleus size, excluding the JWST, of course. However, because the JWST is focused on other things, the Hubble is thought to be the best for this type of discovery. It's been reported that the comet has been hurtling towards the sun for over 1,000,000 years now, coming from the Oort cloud, which is thought to be the home of billions of comets. The inner border of the diffuse cloud is considered to be 2,000 to 5,000 times the distance between the sun and the Earth. So, its outside edge might reach at least a fourth of the way out to the Alpha Centauri system, the closest stars to our sun. But did you know that the comets of the Oort cloud didn't form that far from the sun? Rather, they were thrown out of the solar system billions of years ago by a gravitational pinball game between the bigger outer planets while Jupiter and Saturn's orbits were still forming. Far-flung comets only return to the sun and planets when their distant orbits are disrupted by the gravitational attraction of a passing star, much like apples falling from a tree. Comet Bernard-Anelli-Bernstein has a 3,000,000-year-long elliptical orbit that takes it half a light-year from the sun. The comet is less than 2 billion miles from the sun and is perpendicular to our solar system's plane. The temperature is high enough for carbon monoxide to liquefy off the surface. The size distribution of comets in the Oort cloud, and even its overall mass, is shown by Comet Bernard-Anelli-Bernstein. The mass of the Oort cloud has been estimated to be up to 20 times that of our planet. The Oort cloud, first proposed in 1950 by Dutch astronomer Jan Oort, is still a hypothesis since the bulk of the comets that make it up are too weak and far away to be directly witnessed. Ironically, this means that the greatest structure in the solar system is virtually unnoticeable. What's more, NASA's Voyager spacecraft won't reach the core domain of the Oort cloud for another 300 years, and passing through it might take as long as 30,000 years. Infalling comets that may be traced back to this breeding habitat provide circumstantial proof. Because they approach the sun from all sides, the clouds must be spherical in shape. These comets are deep freeze samples of the early solar system's material that have been preserved for billions of years. The existence of the Oort cloud is supported by theoretical models of the solar system's birth and development. So, the more observational data astronomers can acquire through multi-wavelength studies, the better they'll be able to grasp the Oort cloud's involvement in the solar system's formation. If you want to witness this behemoth yourself, this comet will only be visible to the human eye for a short time despite its amazing size. At 22,000 kilometers per hour, it's speeding toward the sun. But during its closest approach in 2031, it will pass within 1 billion miles of the sun, barely behind Saturn's orbit, appearing as a faint light in the night sky before slingshotting back out into the shadows. Thanks to Hubble's involvement, astronomers can study and analyze this energetic alien guest in all its grandeur, almost as if they were flying right beside it. They'll see a spectral cloud of blue enclosing an apparent dazzling white heart. More of its secrets will be exposed as the comet enters Saturn's orbit. However, when it returns to the sun in 2031, scientists will know nothing about its origins, which are most likely in the Oort cloud, a hypothetical and presently unobservable bubble encircling the solar systems packed with primitive, frozen shards of different shapes and sizes. This humongous comet gives us a sneak peek of what lies at the edge of space, and discovering this entity so far away from us is a reminder of how little we know about our solar system. There are a large number of celestial objects that we haven't even touched on, and a huge number of things we haven't even imagined out there. So, who knows what else is out there? Aliens? Maybe. Thanks for sticking around to the end of the video. Please leave a like, share, and subscribe to our channel for more awesome content like this. Also, please let us know in the comment section below what else you think lies on the edge of space that we could discover as more advanced technology emerges.